Hi everyone, today's real life photo is about dyes. So the first thing I'm going to talk about is the history of the dyes. Before 1850s, all dyes are obtained from natural sources, commonly from vegetables, plants, and trees. Two significant natural dyes are alizarin and indigo. Alizarin is a red dye extracted from the roots of the madder plants. And the other main nature dye is blue dye indigo, obtained in Europe from the leaves of the dyer's wood. Indigo has a very long history dated from ancient Egypt and Asia. It is used in the United States mainly for dyeing cotton for work clothes. For a long time, it was used to produce heavy shades on wool. There is another natural indigo known as Tyrian purple, and it's chemically different from plant-derived indigo only by bromine in the structure. The BASF company began marketing synthetic indigo, which increased the supply of the indigo dye fabric. A wide range of new colorings based on indigo were available, like indigo red, indigo yellow, and etc. So how do we see colors? The first question we have is, what is color? Color is defined as the limited range of the light that we human can see. Here is a table combine visible light spectrum and complementary color to check what color we would see it as. In chemical aspect, the rule is a highly conjugated molecule can be colored. When a molecule absorbs photon of some energy, one electron moves up to a higher energy orbital. So there will be a gap between that one electron in the higher energy state and the electron in the lower energy state. We call it a homolomal gap. This value may correspond to an energy that is absorbed by a photon in the visible light spectrum. If this occurs, the molecule will be colored. Next, I'd like to take a look at the chromophoric groups. Chromophoric molecule is a part of a molecule responsible for its color. Chromophore is a region in the molecule where the energy difference between two separate molecule orbitals fall within the range of the visible spectrum. Oxochrome is a group of atoms attached to a chromophore, which modifies the ability of the chromophore to absorb light. So normally for dye, it contains sequences of conjugated double bonds, like the azo, nitro, and methane group. Additionally, dye also contains conjugated system of the benzene ring bearing a simple unsaturation group, like the anthraquinone, triaromethane, and indigo. Dye can classify by their method of application to their substrate. Or wet dyes is a process that's referred to dyeing that can take place in a bucket or wet. Acid dye is a dye which is a sort of a sulfuric carboxylic or phenolic organic acid. Sulfur dyes are inexpensive dyes used to dye cotton with dark color.
To experience real-life dyeing, we used tie-dye method to color a white cotton t-shirt. The first thing we do is to fill the dye bottle with water and shake for a minute to make the dye fully dissolved. Second, we set up the working surface. We put several paper towels to absorb the extra dye solution on the desk. Then we tied the t-shirt. Last, we applied the dye directly to the cotton. Try to make sure the dye penetrates the t-shirt thoroughly. After waiting for 6 hours, we finally got this awesome shirt. Next, we are going to talk about the application of dye. Have you ever wondered what gives the car you drive its shiny color or the jeans you wear its beautiful blue? Researchers' achievements since the 20th century has resulted into every imaginable color forms of dye. Modern dye serves more than just being pretty. They have become indispensable tools for a variety of industries. From acting as colorants, textile and food dyeing industries are touching our life everywhere. Dyes are also used for inks, tinting, and biotechnology. Today, various dyes are manufactured to meet the requirements of each type of industries. Dyes are available in many forms, such as dry powders, granules, and liquids. In order to experience food dye, Xu Heng and Jay tried the Skittles. The dye colors left on their tongues for a while, so we took these photos. In the left one, Jay ate lemon-flavored Skittles, and the color left on his tongue is yellow, which consists of yellow 6, yellow 5 lake, and yellow 5. Xu Heng tried several grape-flavored Skittles. The ingredients which form this purple are red 40 lake, red 40, blue 1, and blue 2 lake. Among these ingredients, we found out 3 basic dyes used as food coloring: tartrazine, brilliant blue FCF, and allura red AC. Here are the structures. Tartrazine is a synthetic lemon yellow dye which consists the azo group. It is a commonly used color all over the world, mainly for yellow, and can also be used with this brilliant blue FCF or green S to produce a variety of green shades. Reflecting this chemical structure, brilliant blue FCF is classified as a triaryl methane dye. It had the appearance of a reddish blue powder and is soluble in water. Allura red AC is also an azo dye with this azo group. It is dark red powder and usually comes as a sodium salt which is soluble in water. As we could see in these structures, they all consist of the sulfide ion which makes these dyes edible.
There are thousands of dyes used in everyday life. One of the most commonly used dye is indigo dye. However, it's not possible to extract enough of it, all from plants. Thus, people need to synthesize it by chemical methods. One of the best methods is Baeyer-Drusen synthesis, which uses 2-nitrobenzaldehyde and acetone as the starting materials. As both of them are cheap and easy to obtain, Bayer won Nobel Prize in 1905 with his method of synthesis indigo dye. Here's the mechanism of the whole reaction. The first step is a base catalyzed aldo reaction. The sodium hydroxide deprotonates the alpha carbon on acetone and makes it an enolate. And enolates are strong nucleophiles to attack the aldehyde to form this molecule. When acid is in presence, it catalyzes it to form a double bond. And as nitrogen groups are strong in electro-withdrawing groups, it can react with double bond just formed to form a 5-membered ring. And also, when acid is in presence, the oxygen can get a proton from the environment. And the next 2 steps are deprotonations. True water will form and leave out the product. And then again, the hydroxide group attack the carbonyl as a nucleophile and add to the molecule. As we can see in the structure now, a carboxylic acid formed. Carboxylic acids are weak nucleophiles, so it's a good leaving group. What do leaving groups do? They leave. then what's left is the product. And in order to form a new carbon-carbon bond between the rings, we need to convert it into an inert to perform aldo reaction. First to do is to hydrolyze of the molecule. As it mentioned before, nitrogen is an electron-withdrawing atom, so a hydrogen is connected to it and the hydroxide connected to the carbon next to it. And the final step is another base catalyzed aldo reaction, which forms this new carbon-carbon bond between the rings. And finally, when acid is in presence, the hydroxide group will leave and makes this new carbon-carbon bond. What left is the indigo dye. However, like most dyes, indigo dye is not soluble in water. In order to use it, it must be dissolved into water by some chemical ways. One of them is to convert indigo dye into indigo white, which is a water-soluble molecule with a blue-white color, and the mechanism is shown here. Okay, and here are some references. If you want to get more information about organic dyes, please check out these links. Thank you for watching.